Here's a great question. When I'm working on finding least common multiples and greatest common factors, do I really have to list out all those multiples and all those factors? No, absolutely not. So some numbers are just too big and too cumbersome for us to do that with. So let's talk about a different strategy to do that with 2 or 3 numbers. Let's consider these 3 numbers, 405, 36, and 18. Here's my process. I'm going to prime factor those 3 numbers. So 405 splits, I see that that's divisible by 5, and it looks like 81. Now 81 divides into 9 and 9, and then that divides even further into 3 and 3. So once I'm to prime numbers, I'm done. 36, well that's 6 times 6, so let's divide that. 6 times 6, and then 6 is split again into 3 and 2, and 3 and 2 again. Prime numbers there, so I know I'm done. And then 18, let's prime factor that. So 9 and 2, 9 splits into 3 and 3. And then I'm pretty confident I'm done here because those are prime numbers. So I'm going to take these 3 numbers, 405, 36, and 18, and I'm going to make a Venn diagram of the factors that belong to those numbers. So I'm going to have a circle here that represents all the prime factors of 405. I'm going to have a circle over here that overlaps that represents all the prime factors of 36. And then I'm going to have one more circle that represents all the prime factors of 18. So as I put things into this Venn diagram, I'm going to check them off so that I don't duplicate stuff. And I'm going to start in the middle. So what do we see in common between all 3 numbers? Well, I'm seeing 3's show up quite a bit. Do you see how I have 2 3's in 405? I have 2 3's that belong to 36, and I have 2 3's that belong to 18. So I'm going to put 2 3's in the very center overlap of those 3 circles. Let's look at 36 and 18. Do you see how they both have a 2? So I'm going to take that 2, check it off. I'm going to put it in the overlap between 36 and 18. So 18 is done. I've got all its factors accounted for. Let's look at 36 and 405. 36 has a 2 left, and there's no 2 over here in 405, so it looks like there's nothing that belongs in this overlap right here. So let's fill in the rest of 36 factors over here in the kind of crescent shape. That 2 is accounted for. And then in 405, I'll put the 3, and the 5 in, and I'll check those off. I got everything now. All the prime factors are accounted for. So the next step is to find the least common multiple for these 3 numbers. In our notation, sometimes you'll see this, least common multiple of 405, 36, and 18 equals, and then we'll write out our answer. Our trick here is that we're going to multiply all the numbers that are showing in that Venn diagram together. So all the green numbers that are visible here. I'll write those out. 3 times 3 times 5, now moving to the middle, times 3 times 3 times 2 times 2. That's a lot of multiplication. So when I multiply those all together, I'm actually getting 1,620. So that is the least common multiple of those 3 numbers. Let's talk about the greatest common factor. So GCF here. Same notation. So GCF of 405, 36, and 18. We're going to multiply together all the values that show up in that very center intersection. In our case, it's just 2 numbers, 3 times 3. I bet you know that multiplication off the top of your head. That's 9. So the greatest common factor, or the number that goes into all three of these, is 9. So when on earth are we going to use this in other places? Well, we're going to see it a lot in math class. We're going to see it adding or subtracting fractions. We'll see it, if you're not in algebra yet, you'll see it later on. You'll see it working with rational expressions. We'll see it when we're simplifying complex fractions. And as always, you might see this when you're at a party with your fellow mathematicians.